I can't change so put the deposit. And like, you know, so this is not bad. It's like, so they are. When it's like, so they are just kind of like, just and everything. I don't know, you know, it's works. So that you're like, okay, well, I think I'm just really messed up for a minute. And I was like, yeah, but my day, it's 2 weeks. So like, it's not your employees. But the two people had to like they can't that day. But both of them scientifically do like one of the people from high school. I mean, they scientifically don't like say that as great teacher like it's meant. Yeah. So I know it's hard stuff. But yeah, it was just like so they were in the they get to go and a lot of photography. So they like where you look at photos and I think that's pretty good. And I was like, okay. So like if it's a workout, and then I'm like working with she's really good at taking photos, but I think the editing that she that's good. Yeah.
Yes.
Okay, if you can turn to page 21, this is going to be a good representation of what your test will look like. You guys also picked up a morning review. So I think the morning review is good practice for you to do later today, or if you want to come in tomorrow morning, I'll go over that morning review worksheet. So, but today we're going to go over page 21, 22, and 23. Yes. Yes, calculator, you can use calculator on the test tomorrow. Yeah. Okay, so let me just start you off here. It says find f of 4. F of 4 will involve the area under the graph because this is the f prime graph. F prime is simply the order pair. F double prime is simply the slope. But because we don't have a formula given to us, it's not f of x equals the integral of f prime. We have to rely on final equals initial plus displacement. But one thing that I see some students struggle with is figuring out where the shaded regions are. Okay. The shaded region is the region between the graph and the x-axis. So you may be seeing other shapes, like you may be saying, oh, there's a triangle here, there's a rectangle here, there's a triangle here. Remember, we only care about what's between the graph and the x-axis. So see if you can spend a minute to just lightly shade in the portion that we care about. Can you find that region between the graph and the x-axis? Okay, everybody good? So there may be other shapes, but they're not part of the problem if it's not between the graph and the x-axis. Okay. All right, let's find f of 4 rather. F of 4 requires us to know an anchor point. So our anchor point is f of 10. So we have to start there because that is the point that they give us. So on the board there, final position equals initial plus displacement. So I can say, if I want to find f of 4, I'm going to start at f of 10, and I have to go backwards from 10 to 4 of f prime. We always want to follow the definition. And it may end up being backwards, but we can always adjust it later. But we want to always say, okay, I'm starting at 10 and I'm ending at 4 because that's my starting point and this is my ending point. Okay. Now that we realize, oh, this is out of order, we can rewrite it into a more favorable order. And then we can adjust that change with the minus in front. So then we can look at our region from 4 to 10, bunch of triangles here. Let's just find the areas. These are all pretty much symmetric here. So if I can find the area of one of them, I can fill in for all of them, right? So here, this area here is 1/2 base times height, 1/2 2 times 4. Which is 8/2, which is 4. So I know this is 4. These are all symmetrical here. So -4, -4. I'm just going to fill out the rest in case I need it later. So f of 10 is 5 minus, and then let me accumulate all those regions that I found from 4 to 10. So that's going to be 4 minus 4 minus 4, which is -4. And then 2 negatives cancel out. 5 plus 4 is 9. So f of 4 equals 9. I have one piece of my answer. Any questions so far? Integral from 4 to 10 is just these regions added together. Next up, f prime of 7. This is the f prime graph. So f prime of 7 is just going to be the order pair, right? -2, order pair. Lastly, f double prime of 7. This is the f prime graph. So f double prime is the slope or the derivative. So we should figure out what the slope of this line segment is, which is down 4/2. Which is -2. All right, any questions so far? Part B, on the interval between -4 and 12, on what interval is the graph both increasing and concave up? So what I mean by that is at the same time, okay? Not increasing and then separately concave up. Don't give me all those intervals. Give them to me where they're both behaviors are occurring at the same time. So we know that we're looking at the f prime graph. So let's create our slope sine line and line everything up here. So here's my slope sine line. We can label accordingly. Above is positive slope, below is negative slope. On the x-axis, it's slope 0. So start off with our x-intercepts, -2, 2, 6, and 10. Okay. Above the x-axis, we start off below the x-axis. So we start off with a negative slope. Then it goes above the x-axis, positive slope. Still above the x-axis from 2 to 6. From 6 to 8 is below. From 10 to 12, also below. Okay. F double prime. So F double prime is point of inflection. So where do we look for point of inflection? If we're looking at F prime graph. Not the x-intercept, right? It's going to be the what? The max and mins, right? So now there is going to be an overlap here. There is a max that happens to also be an x-intercept. But yeah, that's max and mins. So 0, 2, 4, 8, and 10. I'm trying to line it up with my table with my sign line above, so it's easier for me to kind of spot where behaviors are occurring at the same time. So we start off with a positive slope, right? So positive slope on the F prime graph indicates concave up. So concave up, concave down, concave up, concave down, concave up, concave down. Just going to keep alternating here. Okay, so we're looking for regions where increasing and concave up. So increasing and concave up. -2 to 0. I see an interval there. 2 to 4. And I think that's it, right? We can also tell by looking at the graph as well. Increasing means above the x-axis. Concave up means positive slope. So the only place that we see above the x-axis and positive slope is this interval here and this interval here. Any questions with part B? Part C, let J equals 4x squared times G prime. Find the equation of tangent lines. So we need to find order pair. We need to find slope. To get to the slope, we got to get to the derivative. To get to the derivative, what is involved here? What rule do we have to use to find our derivative? Product rule. And then within product rule, there's also what needs to happen here. Function within a function, so it's going to be its own chain rule inside. Okay. Okay, try that. See if you can build out your derivative. See if you can find your order pair. Be right back. But you guys can check your progress with your key, but I will walk through the problem with you. Okay, let me go through the steps here. So product rule first, since product rule has a larger impact than the chain rule. Chain rule will come in when we get to that G portion of our product rule. So f prime G plus f G prime. 4x squared becomes 8x. We keep the G the way it is. We keep f the way it is, and then G prime is this portion's derivative. Outside, inside portion. So G double prime of 2x times 2. And then replace every x with -1. And then you're just pulling values from your graph. G prime of -2 is just the order pair. G double prime of -2 is the slope of the G prime graph at -2. And then we don't want to forget about the order pair. So we have to plug -1 back into J of x to get the order pair. So 4 times -1 squared is 4. G prime of -2 is the order pair on the graph, which is -1. -1 times 4 is -4. Our slope ends up being 40. Our order pair is -1, -4, and then point slope form. Okay, part D, we see a messy limit problem. Maybe you're thinking, wait, this is maybe a good L'Hopital's rule. Maybe it is L'Hopital's rule, but we always want to make sure that we've met the conditions for L'Hopital's rule. So make sure you do direct substitution first. Only do L'Hopital's rule if we realize there's a hole, right? We got to show that there is a 0 over 0 before we can commit to needing L'Hopital's rule. Because it's very possible that we plug in and we get a real number, we can just stop, right? We don't do L'Hopital's rule unless there's a roadblock preventing us from finding the limit after direct substitution. Okay, all right, so try part D, go through direct substitution first and see if you can convince yourself what that result is before you decide what your next step is. So after replacing all the x's with 2, we should get 0 over 0. And now we have the green light to apply L'Hopital's rule. So take the derivative of the numerator, take the derivative of the denominator. Then once you get the derivative version of your expression, plug 2 back in. Just as a reminder, what's the derivative of 1 over e to the 5th? Good, 0. And then 4 is also 0. Good. So make sure if we see pi or e, just treat them like constants. We don't do power rule with them. They're just numbers. Okay. So e to the g prime becomes e to the g prime times g double prime, right? We're just following the rule for e to the u times u prime. Denominator g of 2x becomes g prime of 2x times 2. And then 4 goes to 0. Oh, I do notice this issue that students have is sometimes we forget that we need to be taking the derivative of constants. And I see some students carry the constant into the derivative, and that just throws everything off. So just remind yourself, oh, every term is getting impacted, even the constants. So in this case, my constants are both dropping out to be 0. We don't want to keep that 1 over e to the 5th nor the 4 when we find the derivative. So those 0 out. Okay, and then once you find your derivative, replace all the x's with 2, and then you're just trying to get it down to a number. So g double prime of 2 is 3, g prime of 4 is 2, -2. And I'm just combining it. You can leave it like this. I like to have my answer with positive exponents, so I brought the e back down to the denominator. But unsimplified is okay. Okay, next page. Okay, is there a time such that g triple prime is equal to 2/5? Well, if we had a g triple prime table, we could just go down and see if that value shows up, but we don't have the third derivative shown to us. What we do have, though, is g double prime. And we know the third derivative is just the slope of the second derivative. So I think this is trying to get us to use mean value theorem here. So see if you can find the slope between the two endpoints. And see if that slope ends up being 2/5, because if it does, if the slope of my g double prime graph can show a slope of 2/5, there must be a place where the third derivative is going to be matching exactly 2/5. Okay, so try that. See if you can find your order pair that you want to use. Change in g double prime over the change in x. So I get 2 minus -2 over 6 minus -4. I get 4/10, which is 2/5. So we do get that confirmation. But because it's mean value theorem, we also want to make sure that we state our conditions. So by mean value theorem, since g double prime is continuous with brackets and differentiable with parentheses, there exists a value c where g triple prime is equal to 2/5 on the interval from -4 to 6. So notice the original mean value theorem is saying the change in slope of my f graph is going to be equal to prime. We can adapt mean value theorem for further derivatives. We can do the slope between 2 points on the g double prime graph to prove that there's a g triple prime value. Okay, part F, find k prime of 3. We should see that there's kind of nested chain rule going on here. So we got the g prime as the outer, and then the f prime of 2x minus 1 as the inside. So see if you can build out your derivative using chain rule. and then you can plug into 3. So first steps first, we don't want to plug into 3 yet until we have the derivative built. So try that. Okay, so the outermost function is the g prime. Then we can worry about the g f prime. So g prime becomes g double prime. We keep the inside intact. Now we're ready to move on to the inside portion. F prime's derivative is f double prime of 2x times 2. And then the minus 1 goes away to 0. So that's why I didn't have to include it over here. Okay, replace all the x's with 3. And then you're just off to using your table or using your graph to get it down to a number. G double prime of -1, we can pull from our table. F double prime of 6, we can pull from our graph. We know F double prime is just the slope of F prime. Okay, part G, find the maximum value. So that's extreme value theorem. We want to pull our candidates from our slope sign line. So you can go back to the previous page, look at your slope sign line, and you just can pull off your critical points. And we don't have to worry about relative minimum. We only have to worry about relative max and then the endpoints. And that should be enough. Okay, so if you go back to your slope sign line, you can see that we have critical points at -2, 2, 6, 10, but we only need to test 6 and -4 and 12 because -2 is a relative minimum. There's no way that could be a max. 2 is neither a max nor a min, so that we don't have to worry about. 10 is neither a max nor a min, we don't have to worry about that. So just -4, 6, 12, right? And then don't look at the second derivative sign line. Your point of inflection is not going to play a role in helping us find max and mins. So we're going to have to go through this formula multiple times here, right? Starting point is your anchor plus your displacement. So f of -4 is f of 10 plus however much progress I want to make from 10 to -4. The order is off. So after I write my definition, I'm replacing my bounds or changing the bounds and pulling the negative out. And then I'm just adding up those areas between -4 and 10. So -4, because below the x-axis, +8, +8, -8. Combine that, I get 1. Okay, repeat the same process for f of 6. F of 6 equals f of 10 plus that gap between 10 and 6. 10 and 6 is still out of order, so I can flip the bounds, pull a negative out, and then I can just read the graph from left to right. From 6 to 10, my region is below the x-axis, so -8. 5 plus 8 is 13. F of 12. This one, I don't have to change the order, the bounds, because My definition already gives me from 10 to 12. So just keep it the way it is. 10 to 12 is that triangle below the x-axis, -4. So 5 minus 4 is 1. Compare all these values. The maximum that we see is 13. So that's our max value. Part H, if you see a messy integral problem, then you should consider U substitution. And if you're thinking, well, where's the U value going to be? It's going to be in your set of parentheses. But the 2x is a little bit too small. We need to create a larger set of parentheses, and that's going to come in the form of that G prime of 2x. We're going to surround that G prime of 2x with parentheses to the 1/3. If we can rewrite the radical using a set of parentheses or brackets, then inside that portion, it's going to be a good candidate for our U value, because we need something large enough for G double prime of 2x to go away. So we do need our U value to be G prime of 2x so that the derivative will eventually make its way to cleaning up and getting rid of that G double prime. All right, so try those steps for part H. Notice that the derivative for G prime of 2x is a little bit of chain rule here. So G prime of U times U prime. So G prime of U becomes G double prime of U times U prime. Cross multiply, replace, solve for dx. We get the G double prime of 2x to cancel out nicely. The 1/2 gets pulled out, and now we have a really nice and clean power rule problem for us to solve. Apply power rule. Make sure you bring back your original x variable, and then you can plug in your upper and lower bound. G prime of 6 is 1. G prime of -2 is also -1. You can leave your answer as in this form. That's fine, as long as you get everything down to a numeric value. Okay. And then on the AP exam as well, leaving answer unsimplified is the preferred form, because first off, you save time. And second, if you make a mistake cleaning up, then they may take a point off for that when you could have just earned full credit by leaving your answer unsimplified. So. Okay, we didn't get a chance to get to page 23, but I think you guys can try those on your own. It's just average value theorem, finding slope, and then evaluating the integral. So your test is basically going to circle around these types of problems. Okay, can you read the graph? Can you read the derivative graph? Can you interpret the derivative graph? Can you find points of inflection and understand how to create your slope and concavity sign line? Can you do power rule, product, chain, and quotient rule? Can you identify limits where L'Hopital's rule can be involved? Mean value theorem, extreme value theorem, U substitution. So it's going to be those topics. Tomorrow morning, 7:15, I can go through the rest of page 23 as well as the morning review that you picked up. Okay. All right, come get your phones.
You didn't mark me absent.
Sorry, I'll change it.
Okay.
Thanks.
I think it's just needed.
Yeah. Okay, thank you.